Hi everybody, I'm Professor Adam Teman of the Unix labs at Bar-Ilan University, and today I'll be giving you a first introduction to the Linux command line. So what is Linux? Linux is a family of open source Unix-like operating systems. The Linux kernel was released by Linus Torvalds in 1991. So we have this guy to thank. It's provided under the GNU General Public License. Why was it developed? Well, in those days, we used to have to go and buy one of these workstations that cost a lot of money. It was really for businesses and so forth. And Linus Torvalds came and he made a porting of Unix to an x86 architecture so we could run it on our personal computers and so forth. And nowadays, it's ported to more platforms than any other operating systems. In fact, Android, which you probably know well, is based on Linux. Linux is usually packaged as a distribution or what we call a distro. Distros are called Red Hat, Fedora, Ubuntu, CentOS, SUSE, and many others. And a distro basically it combines the Linux kernel with all kinds of other programs that run on top, such as a windowing system and a desktop environment like GNOME and KDE. So the different types of things we'll be seeing here are parts of just a general Linux distro that you'll probably be seeing something like that. We're going to talk about the bash shell. The interface to the operating system is called the shell. This is a program that it allows you to run programs and to give input to programs and inspect the output of programs. And the shell that we're going to use is called bash. It's the born again shell. It's the most popular Linux shell today. In the past, we had the first shell that you used to run on Linux was called SH short for shell. Then there was CSH and TCSH, and in many of the different types of old school industries like chip design, we still use CSH as our basic, but many years ago, people moved over to bash, which is kind of an easier and more popular shell. So first we open a terminal, usually by something like right-clicking on your desktop environment and select Open in Terminal, and that will give us a prompt. So let's start with a hello world. Every programming course has to start with a hello world. So how are we going to do that? We're going to tell bash to print out hello world, and we'll use the command echo. The command echo is just a program. So we'll write echo, and we'll give it the arguments hello world, which we're going to put inside quotations over here. So echo is really just the name of a program, and hello world is the argument to that program. So here I am at my command prompt, and I can write echo, and then with a single quote, hello world, bang, and an ending quote. And as we can see here, it returned to me hello world, as we can see over there. We can try other programs. For example, date. What do you think date's going to do? So if I write date, what I get here is the date and time of when I exactly recorded this. So how does the shell know how to find the programs that are called date or echo that we just found? Well, it's going to search through a list of locations on the file server. Okay, so where is this list stored? There is a variable, an environment variable that's called path with capital letters. Okay, so there is this variable called path that has a list of locations that we should look for whatever program we just wrote in the command prompt. So how are we going to know what are these locations that it's looking for? And that we have to dereference this variable called path. So how are we going to dereference it? We're going to write echo. So it's just going to repeat what we just said. I mean, we have that kind of ridiculous echo program we saw before. Why would we ever use it? Well, one of the reasons is to see what path actually means. So we go echo $. That is going to dereference the variable name that comes after it. So $path is going to give us what the variable path is equal to. And this gives us a list of locations on the server which are used to search for programs. So if I write echo $path, what I get is the path. So as I can see here, there's this thing that says /bin, and this colon is the separator for a list, user local bin, user bin. So these are different things in my path. And that means that when I write something like echo, it will go and it will search if it's in bin or if it's in user local bin or if it's in user bin. The first one it will find, it will run that program. So how do we know actually where it found the program echo or the program date inside the list of locations that we had in path? We can ask Linux. So how would you ask it? You would ask it which. So I write which date. and it will go run through the list of locations that we had in the path variable, and whatever it found first, it will return to us. And we see that it is stored in a folder called /bin. Well, that's not surprising because bin is short for binaries. And so usually compiled type of binaries that run our programs are going to be in some sort of a folder called bin. And slash is going to be our root directory. So /bin is where basic programs such as echo and bin and which and others are going to be stored. Alternatively, we could have run it directly on, we could have directly run that program. So we, instead of looking through the path, we could have run /bin/echo. That's the absolute path to the echo command, and then provided the arguments, which are hello world. So how do I know which one was found? I write which echo, and I see that in /bin/echo, I have it. I could have just run /bin/echo, and then something like, hello, and I see that it returns hello to me because I directly ran that. So we're inside the shell, and it's a very important thing that we have to navigate inside. We saw that there are these things that we called locations in the Linux environment. I mentioned before that we have this slash, and that is the root of the file system. Basically, the file system is a big tree, and the first place where everything, the top of the tree where everything starts from, is this slash, this root. All the directories and files lie inside the root. So there may be files in here, and there may be directories that have files inside them and directories inside them, and so forth and so on. So we're going to traverse down this tree until we get to the actual file that we want to run or work with. Okay, and there's a very important thing that we have a location. The place that we are currently working, the current working directory, is the location that we're at. Usually we start at what is called the home directory. It's such an important directory that it actually has an alias, which is a tilde. So when we talk about tilde, that's our home directory. It is actually a place that's underneath the root. So again, we have a big tree, and at the top of the tree we have our slash, that's our root directory, and our home is down below beneath the slash, but just to easily get to it, we use this tilde as an alias. How do we know what the real path, for example, of our home directory is, or where we are right now when we start our, when we opened our terminal? Well, we'll write pwd. Pwd is print working directory. That will print out basically what the current working directory is. And then we'll see that we're in, some sort of a directory underneath root. That is our home. Okay, each user, when they log on, will get a different home, and they will usually start over there, and when they write pwd, it will point to their home. We can also see what the directory is by looking at another environment variable called home. So echo $home, $home will show us what our home is, and it will be the same as our tilde. That's where we are right now. And this concept, again, of where we are now is really important. We have to know where we are because everything that we do is relative to where we are now. If we want to look at directories that are underneath us, we are going to start from our directory and go underneath. For example, in our home, we probably have a directory called desktop and downloads, and so we don't have to do anything but reference to them. And if we're at root, we can go from root and keep on going down until we get to home or different directories that we have. So let's run pwd, and we see that pwd returns /data/home/teman_ad. That is my home directory. I can also, again, do echo home, and I see that it returns the same thing. We can actually navigate relatively through the directories with cd, and cd is for change directory. And change directory, we can either give a relative or an absolute directory. So if we do cd/, we're going to get to the root of the file system, or cd/bin, we'll get to the /bin directory. But usually we're going to start where we are at our current working directory and then go relative to it. So the two real easiest things to do are dot and dot dot. Dot dot is going to go one directory up to the parent directory of where we are right now. And dot is our current directory. You don't usually need to use dot, but if we use dot, then it kind of explicitly says start from the current directory that we are at and go down from there. We can actually, we could have written cd Teman AD without the /Teman AD. I can go up one level by going cd dot dot. And now if I do pwd, I see I'm now at data home. If I want to go back into Teman AD, I can do cd slash Teman AD. Oops, cd dot slash Teman AD. And I see that now I'm back again at data home Teman AD. I could have done just a bunch of different things. First of all, I could have done cd minus would return me there. Or I could have just done cd Teman AD because it is a relative path. And you see also that this is also called tilde. So I could have done, again, cd dot dot. Now I'm somewhere else, and I can go cd tilde. It will return me to Teman AD. I can use absolute paths. So for example, if I want to go to where we found echo before, I can go cd slash bin, and now my pwd is in slash bin. And you see that that's how I can go back to my home directory and so forth and so on. So really, I can navigate up and down and around, either with relative or with absolute paths. To see what files and directories there are in the current folder, we're going to use one of the most important commands in Linux, which is ls. Remember, ls and cd and all of these, they're just programs that are probably inside the slash bin folder. So ls, if we write ls, we'll see all of the files and the directories that are in our current working directory. For example, if we want to see a specific file, specific file or a specific folder, we can give it as an argument. So ls./downloads or just ls downloads will show us the directory called downloads, or actually show us what's inside that directory. And we can do all kinds of things with that. There are flags and options in most Unix commands, and specifically in ls. So for example, ls-l is going to show us the directories in a list view, in a detailed list view. So usually options are going to start with a minus. They can also start with a plus or just with nothing. It just really depends on the command. How are we going to know that? Well, we can search for it on Google and then get a nice HTML page that will kind of show us all the options and so forth. But we can also use two options. One of them is to ask for help. Most of the time, it will start with something like minus help or -h, and then it will print out something like a list of all the options that that command has. But if we want to get detailed explanations of what each of those options does and how to use it in examples, we can usually look at the manual pages, which we access by writing man and the name of the command. Not all commands have manual pages, but many of them do. So to see what files I have in the current folder, I will use ls. So when I do ls, I see that I have these different files in my current folder. If I go to a different folder, let's say slash the root, right? I can do ls/. I see that there are all these different things inside the root folder that we have over there. One of them that I can look at, for example, is /etch has all kinds of junk in it. So you see that there's a lot of things here. That's really kind of hard to look at. So what I'll usually do is use ls-l, which will actually show me a detailed list of what I have. Or let's say if I did that on etch, you see that I have a ls-l /etch. Then you see that it shows it in kind of a longer list with all kinds of other things. How did I know that I could do ls-l? Well, I would have done something like ls-help, and then it will show me a help status of all the different things I can use over here. And these are the information of how to use with all of these different options. I also could have just done man ls, and you see that it gives me a whole explanation, a manual page. It could be easier just to Google it and look at the Google entries of that. But if I go down and I find -l over here, it says use a long listing format. And that's what we've been using. If I hit Q, it will quit that, as we'll see in a moment. We can also use what we call globbing or wildcards to match many strings. Now, this is a very important concept in general, and it's used in many different things, but it's really often used in a Linux shell. So globbing is basically two main characters. The first one is a question mark, and a question mark means match any single character over here. So if I write ls and I give it as my argument, my file, with a question mark, what that means, it will match any file or directory that is called my file with some other character over here, my file A, my file 1, my file 20. sorry, it will not match my file 20 because it's only matching one character. If I wanted to match my file 20, I'd have to put 2 question marks, or my file question mark 0, or my file 2 question mark will match my file 20. So actually, the question mark is not as useful because it only matches really one character over here. What we'll usually use is an asterisk, a star, which will match one or more characters. So if I do ls my file star, that will match my file 1, my file 20, my file is very big. Okay, so it will match all of those. So stars are really useful. I can do something like my file star 0, it will match my file 20, my file 30, my file 3000. Okay, so that's a really nice thing to do, is use this star wildcard. There are a few more options in globbing, but really those are the ones that are mainly used and found. So let me show you how to use globbing. If, for example, I went to ls etch, right? And I have all of these things, but I only want to see the files that actually start with an L. So what I can do is, let's say ls minus L. I'll use D just to clean up a bit of the junk that will come out. I do /etch /L star, and then it will only show me the files that started with an L. As you can see, it only returned those ones over here. And so that's one way I can use globbing. Let's say I only wanted to show the ones that had two letters after that were only five letters long. So I could have come over here and L, and put 4 question marks, and then it will only return for me this lib NL type of a thing because I only put 4 question marks after the L. Or I can just show all of the files that are under here that have 5 letters. And you see that all of these have 5 letters in them. So these are different things that I can do with globbing. So I just wanted to mention, if we're already looking at directories, something that is known as dot files. Many programs are configured with plain text files that are known as dot files. They're called dot files because their names start with a dot. And in Unix or in Linux, when a name starts with a dot, it's actually hidden. So when I just write ls, I will not see it. So when I wrote ls on my directory before that, I didn't see that many files. But if I actually add the -a option, which will show the hidden files, I see that there's a whole lot of these files that start with a dot that I didn't see before. And again, they're usually used for all kinds of configurations and things that you don't want the user usually to deal with or look at, or that you don't want it to bother his eyes. So we hide them unless we use the -a flag for all. Okay. What are important dot files? There are a lot of them actually, and many different programs that we install will provide their own dot files. But for example, in Bash, we have the .bash rc file and .bash profile, which will be run every time we open a terminal, and they'll configure all kinds of settings for our Bash shell. Different things that we use like git, vim, ssh, they'll have their own dot files like .git config, .vimrc, .ssh config that will really help us to configure these different types of programs. So if you really want to find something that may be hidden, it may start with a dot, and then you'll have to use ls -a to see it. So again, when I just ls my home directory, I see that there are a bunch of files. I can do this in a detailed way. But when I actually add the -a option, so I can see that there are a lot more files, right? And I have things like bash rc and bash profile and different things like that, .ssh, and other types of files over here that are hidden in general. So I can do things like ls.bash rc, and I can see just that file. But if I would have just done ls, it doesn't appear here. So now we know how to go through different directories and to list what's in them, but there is something that we must know at this point, which is called file permissions. So files, when we create them, they have something that is default permissions. In other words, who can access them? And how can they access them? Can they read the file, just see its contents? Can they write to it, or maybe it's a read-only file? And can they execute it? Can they use it to run code? Those are the 3 options that we have: read, write, and execute access. So let's create an empty file with the touch command. So touch is this kind of ridiculous type of a command that all it does is it creates an empty file. So touch my file will create an empty file that is the size of 0 bytes. Then we can show information about the file by writing ls minus l. So we have a detailed list of the file. And what we get is this long type of a string over here, as you can see. So what do we see over here? Well, let's start by looking at this area over here. And if we see there are three characters, these three characters can be three dashes, or they can be any combination of R, W, and X. Well, R, W, and X set up right along with this read, write, and execute. So what this means is these three characters show the permissions that the owner or user of the file has. Does he have read permission, write permission, and execute permission? Now, who is the owner of the file? The owner of the file is Teman AD in this case. That's me. So when I create a file, it's usually owned by me, and it gives me permissions on it. And in this case, the default permissions are that I have read and write permissions to this file, but I do not have execute permissions to this file. Unless I explicitly tell it to, I cannot execute the file. Okay, and that makes sense. Most of the files are going to be some sort of a text file or a data file. They're not going to be actual programs. If I want it to be a program, I have to change the permissions to make it executable. So that was these three characters. What about the rest of them? Well, there are other trios over here, these R, W, and X characters, which show the permissions that the group has. So each user belongs to several groups in Linux, and therefore I can set permissions to files and to directories according to whole groups that I set. So the group over here has read permissions only. The group can't write to it, only the owner can. And what is the group of the file? To which group does the file belong to? Well, that's this second string over here. So in this case, it belongs to a group called ngguest, and that was the default group that we decided to give permissions to in our default. Again, this is something that we can change and manage. Okay, and the third one is for everybody else. So we have read permission only for both the group and everybody, but we have read and write permissions for the owner. What else do we have over here? There's another dash over here. That this dash means that this is a standard file. If it was a directory, it would say D over here. And another thing we have over here is the size of the file. So the size of the file is right now 0 bytes. Okay, and of course we have the last modified date of the file, which is very important for us to know. So now I'm going to write touch my file, okay, and then I'll do ls minus l my file. And what I see here is that my file was indeed started with read and write permission for me, for the owner, read permission for the group, and everybody has no permissions to it. And this was owned by me and part of Teman AD sock group. And this is the date, and this is the size of the file. So how can I change the actual file permissions? With the program chmod, change mode, or chmod. So if there are lots of options how to use chmod, and you can look at the man pages and see all kinds of examples and so forth. But for example, I want to make the file executable, so I do chmod plus X on my file, and it will provide X's in the owner, and in this case the group too, maybe the others as well if they have read permissions. I can make the file writable only by the group members, for example. So I do chmod G plus W, and that will add an X only in the group area. Okay. One of the common ways to actually access this is to take this as a collection of bits. So there are actually, 9 bits over here, or three threesomes over here, and each threesome is basically an octal character. So with 8 numbers, I have 000, 001, 010, etc. And so I can use that to tell which bits over here to light up and which not to. So for example, 6 is 110. So chmod 666 will do 110. So read, write, and not execute. 110 read, write, not execute, and 110 read, write, not execute. So a way to make the file readable and writable to all is to do chmod 666. If I want it just to be, for example, the owner, I can do 600 or something like that. So there are lots of these options on how to change the permissions to files. If I want to do something like make it executable, I can do chmod plus x my file, and you will see now that if I do again ls my file, everyone now has execute permission to it. Not that it will do anything much. Okay, and I can also do something like chmod 666 to my file, and then we will see that again what I get here now is that everybody has read and write permissions to my file. The next issue is redirection, and this is one of the basics of Unix. So what usually you have is this something called the standard input and standard output. And the standard input and the standard output of your program are basically the terminal, the prompt we have. So the input is provided by the keyboard, typed into the prompt, and that is what gives the input to our whatever program we're running. And the output is actually sent to the screen so we can see it. But sometimes we don't want the input to come from the keyboard or the output to go to the screen. Usually it's that we don't want the output to go to the screen. And therefore we can use redirection. So we can redirect the input-output streams using this smaller than and larger than. So when I do smaller than in the name of a file, the input will actually be redirected to come from a file instead of coming from the keyboard. And when I do larger than and the name of a file, the output will be redirected or written to a file instead of written to the screen. So for example, if I want to print the string hello to a file instead of to the screen, what I can do is I can write echo hello. Echo hello is just going to obviously return the string hello, right? It's going to print the string hello underneath my command line. But instead of printing it to the screen, I ask to redirect it to a file that is called my file. If the file doesn't exist, it will create this file. If the file does exist, it will overwrite the file. And now I will have a file that's contents are the string hello. Well, to see that that worked, we can use the cat command. Cat is one of the file viewers that just prints out the content of a file. So cat, my file, should print out the content of the file, which since this is what we ran beforehand, will just have the string hello in it. Okay, we can do something like kind of more fancy. This is not something that you're going to use often, but just to show you how you can use the input to be redirected as well. So we can redirect our file is going to be used as the input to the cat command, and the output is going to be redirected into the new file. So what we do have here is cat, instead of just doing cat my file, it actually would do pretty much the same thing, but I can redirect the content of my file as the input into the cat command, and then redirect the output into my file too. And what that's going to do is going to basically copy the file. I can do it in an easier way, we'll see in a minute, but I could really use this to write hello into my file too. Again, this is just a kind of a fancy example, not something you're going to be using much, but doing redirection by redirecting the output is something that we're going to do often, as well as pipes that we're going to see in a moment. Another thing that I can do is to append. That means if I did this, right, I overwrote the file, as I mentioned before. But what if I wanted to add, world to my hello? So I can do echo world, and that I can append to my file too. So if I use these two larger than signs, it's going to write whatever my output is to the end of the file rather than overwrite it. So now my file is going to have hello and world inside. So if I do something like echo hello to a file called hello, then what I can do then is cat hello, and I'll see that my file just includes hello. And I can do something like, echo world, and I will append that to hello. And what now I get when I do cat hello is I'm going to get hello and world, as you can see here. So that's how I can do these things. Again, if I would again run echo next hello or something like that into my file that's called hello, it will overwrite it. So then I do cat hello again, and I see that it's now erased what I had there, the hello world, and it wrote next hello. Another thing I just want to show you is that if I do ls minus l, now the size of this is 11 kilobytes and not that same 0 bytes before. What other basic commands should we just know about? So let's say I wanted to make a new directory, so I use the make dir command. mkdir is make directory. So if I do mkdir my directory, that's going to create a new directory called mydir. Okay. What if I want to erase that directory? I'll do rmdir my directory. But just so you should know, if I try to remove a directory that's not empty, it will fail. How about copying a file? Well, the cp command is to copy a file. So instead of doing that input-output trick, which is not very efficient, I could do cp my file copy, and now I will have a new file called my file copy, which is an exact copy of my file. I can move a file. Let's say I could have copied this to a different directory, but now that I made this my file copy over here in this directory, and I wanted to move it to a different directory, or I just wanted to change its name because I don't like this name, I can use the move command. mv my file copy my file2 will change its name from my file copy to my file2. If I would have put a different directory name over here, it would have moved the file. And to delete a file, I just do rm. That's to remove, right? Rm my file2 will now erase this file. So I can create a directory. Let's say I do make dir my directory. And then if I do ls-l, we will see here now I have a directory called my directory. And I can do ls my directory, and there's going to be nothing inside my directory. I can create a file inside my directory called my new file. And then if I do ls my directory, I will see that there's a file inside of it. Okay, I can remove that directory by doing rm my directory, but it will not allow me. And the reason is that I just did rm. I have to do rmdir my directory. And then you'll say it can't remove it because it's not empty. So I can remove my directory, whatever's inside it, my new file, and then I can do again rmdir my directory, and then it removed my directory, and I can again do ls-l, and you'll see that my directory does not appear anymore. Okay, what else can I do? I can copy a file, so I can do cp my file to my file2, 3. And now if I do ls-l, I have 2 my files over here. Again, they're both empty at this point, but let's say I would copy hello into hello2, and then I can again cat hello2, and you'll see that I just made a direct copy of it. I can, of course, erase that, so rm hello2, and now if I do ls-l, I do not have that hello2 anymore in the list over here. Finally, I can use a command called find, which is a very strong command, which will help me find files and do all kinds of things to them. So basically, if I do find dot, that will look for all the files that are underneath the current directory. Remember, dot is my current working directory. But it will go recursively and look through all the directories that are underneath here. And then -name my file will automatically filter out all the files except for the ones that are called whatever this string is. So find dot -name my file will find all the files called my file under the current working directory recursively. Okay, I can also do all kinds of operations to whatever is returned there. So find dot -name my file again is going to return all of the files that are under this directory, and then -exec will execute a certain command to them. Which command do I want to execute? Remove. I want to delete them. This is the file name that is returned, and I have to add a semicolon to finish the command. So that's kind of the syntax that it uses. Be careful when you do something like this, of course. Find command with find dot will show me everything that's under here. So that's not what I wanted, but if I wanted to do the find dot /name my file, it will return my file. If I do find dot -name and then I do my file glob, it will find all of the files that are called my file that are under here, including one that's under the directory called desktop my file. Now let's say I want to erase all of those. I can again do find -name my file star, and then I can do -exec rm, and this will erase basically everything that I have there. I have to add a semicolon after it, and when I do that, now if I do ls-l, I will see that there are no files named my file, and if I do ls-l in desktop, I will also see that I don't have that file there anymore. Some other basic commands that we want to know are history. So if I write history, I'm going to see the last commands that I wrote. I can also add a number here to see the certain number of commands, the last 10 commands, the last 2 commands, the last 100 commands, etc. I can look at my history. I can look at only 10 things from my history by going history 10. It will only show the last 10 things of my history, and I can rerun one of them. Let's say I want to run ls minus l, and I see it's on line 1149, so I can do something like bang 1149, and it will rerun that ls minus l. So that can be really useful to use. Viewing files, there are many ways to view files. So I can use the cat command that I showed you before that just prints out the content of the file on the screen. But that can get cumbersome if I see that there really is a lot of text or whatever inside my file. So therefore, we have the more command, which will show it page by page. But more was replaced by a better command called less. And the less program is similar to more, shows us page by page, but has a lot of options like searching in the file and going up and down with the keyboard and all kinds of really cool things. I love less, by the way. Okay, Vim is one of the two major kind of text editors. One of them is Vim, the other one is Emacs, and there are people who really fight between them. Which one is better, Vim or Emacs? So Vim will open a text editor, as I will show you before, and you can do all kinds of word processing on the file. Nano is a real simple word processor that might be easier to digest when you just start with Linux. Now, as we saw, we can view files. So I had this file over here. If I look at my my directory, I have a really large file called files list over here, which is 1.6 megabytes long. So if I do cat files list, it's going to be really long, and I can't really see anything inside. I'm going to have to go with my mouse and scroll up, and at some point, my screen the buffer will end over here. So what I can do is I can run more files list, and then it will show me page by page. But you see, it's not going very far. I'm still at 0%. So I'll hit Q to quit that. And what I would usually use is less files list. Less is much nicer. I can go down by pressing the space bar. I can go up by pressing U, down by pressing the space bar, up by pressing U. If I press slash, I can look for something like, let's say I look for the word layout. I can see that it finds layout, and pressing N will jump between the searches. Pressing Shift N will jump backwards to the next found search query. And I can do, GG will send me to the top of the list, and Shift G will send me to the end of the list. So there's lots of things that I can do here with less. It's a really nice program. I can also use Vim to open files list, and Vim is a editor, so I can go around and I can do things. I can change this to something else, or I can delete a line, or all kinds of things like that. I don't want to do anything, so I'll do :Q will quit. It says no right to the last change, so I do Q bang, and it will go out. And I can use something like Nano also for files list over here, and then I get kind of a more, I guess, user-friendly type of a word processor. Control X will exit it. Okay, so those are different types of viewers that we have. Another option is to do something like show the beginning or the end of the file. Let's say we have a log file and we want to see what the date and time that the log file was produced at. So we can do head my file. It will show only the first few lines of the file where the date and time will probably be printed. And let's say I want to see if it completed successfully or completed with an error. That'll probably be at the end of the file. So instead of opening the file and printing the whole thing on the screen, or opening it with less and then going to the top of the file and the bottom of the file, I can write tail my file. It will show me the last few lines where it will show, exited with error such and such, or completed successfully. Now again, what if I just want to show the first few lines or the last few lines of a file? So for example, I can do head files list, and I can see it only showed a few lines. Let's say I only want the first 3 lines. I can do something like head -3 of files list. It will only show the first 3 lines, or tail -20 of files list will show me the last 20 lines of files list. So head and tail are also really worthwhile using. Finally, we can compare files with the diff program. And diff takes 2 files and compares them, and it will show us each line that has a difference in it, and it will print it out on the screen. Sometimes that's really hard to really debug things. It will show us a quick difference between files if we have different versions and so forth. But there are other programs such as tkdiff or meld or even gvimdiff that will give us some sort of a kind of UI for really comparing between files. So we have a file here called names. So as you see that I have this list of a bunch of names. Let's make a copy of names to names2, and then let's edit it. So let's edit names2, and for example, we'll go over here and we'll change Charlie Brown into Shirley Brown or something like that. And then I will go diff names versus names2. And what do I get? That in line number 3, Charlie Brown and Shirley Brown are not the same. In names, which it shows by this like left pointing arrow, I have Charlie Brown, and in the right pointing arrow, that's names2, I get Shirley Brown. There are other programs that are much nicer for doing that. For instance, I can use meld for names and names2. And if you have meld installed on your system, it will really show a much nicer type of a view of how this is done. So you can use these types of things as well. So I promised you we would come back to more redirection, and pipes are a very strong option for redirection in Linux. That once you get used to them, you use it all the time. So the pipe operator lets you chain programs such that the output of one is the input of another. This is a pipe. And now I don't know how much you're used to finding this character on your keyboard, but it's usually by using shift with a backslash, which is right next to the return key on your keyboard. And in fact, backslashes are used often. So make sure you find that. And usually the pipe is when you shift to the backslash. So for example, and this is just a pretty bad example, but if I do ls minus l and I print out all the content of my current directory, I may have a lot of content over there, and I only want to find the files that start with my with the letters my, so I can pipe the output into a command called grep, which will only return the files that start with that have a word that starts with my. I could have done this by using find with the minus name, but I just wanted to give you as an example. In fact, I wanted to show you that grep exists because grep is one of those programs that all Linux users, they just love it. Grep, again, goes through the text inside a file and will return all the lines that adhere to some sort of string. It has many, many options, which are really, really cool. So you should really learn about using grep. Somebody who deals with Linux a lot uses grep all the time. So what piping, again, is going to do is going to take the output of one command and put it as the input to a different command. And of course, I could have taken the output of this and redirected it into a file or all kinds of things. We can really make these long one-line, Unix commands that keep piping things until we get these real cool options that it does. So I was going to show you how to pipe things. So if I do something like ls minus l, we see we want to find only the names that have hello inside. So one of the things that I could do would be to do ls minus l and then take the result and put it into grep and grep out of it. What did I want? Names, right? So I can do something like that, and it will return me only the lines that had names. If I just had put ls minus l, it returned me this whole thing. When I grepped it, I got the ones that had names inside of it. So that is what I can do with piping. I take the output of one command and I pipe it into another command. We can also do something else, which will take a command and run it inside the command line and return it and use it. So for example, here we have echo, the current date is, and we want to print out the date. So we invoke the date command. We take the output of the date command, and by putting $ and these parentheses around it, it will return that and replace it over here. So it will give us the date as said. In older systems like C shell, we use backticks. In Tickle, we'll use these square parentheses. So there are different ways to do it in different shells, but in Bash, it's done in this way. So echo the date is, and then I can do $, and in between these parentheses, I can set another command. So that command is date, and what it's going to do is the date is and returns the output of that command and prints it over here. Okay. So that is something that's really nice to do in many cases. A very useful thing are aliases and symbolic links. So we've been showing you that different commands have all these options, and it's really hard to remember them, and it's really cumbersome to write them all out. So for example, ls minus l is something that's pretty cumbersome to write out, and we use it all the time. In fact, something that I often do is I want the files to be sorted by the last time they were modified. I want the last one on the list that appears, at the bottom of the printout to be the one that was most recently modified. And I don't want it to say, how many bytes the file was made out of, but how many kilobytes or megabytes or gigabytes or whatever. So I need minus L, minus T, minus R, and minus H. So instead of writing ls minus LTRH, I will usually use what we call an alias. I will say LL means ls minus LTRH. So I write alias LL equals ls minus LTRH. And from now on, every time I write LL, it will actually run this command. If I want to go back to the original command, if I overwrote what an original command is, I can use backslash in the name of the command, and then it will give me the original command. So we do this often. So for example, gv is grep minus v. That's just like grep, which searches for a certain string in file. This one will return all the lines that don't have that specific string. Or grep minus color minus line number will actually color the things that grep returns and say which line number it was on. So these are kind of useful aliases. And in fact, in your .bash rc, and maybe you have your own file called myaliases or something else that will be loaded every time you open a new terminal, you will put in the aliases you commonly use and get really used to using them instead of writing these things all out. If we want to see all the configured aliases, we will type alias. Now this can be very long, and therefore what are we going to do? We're going to take the output and we're going to pipe it into less, where we can actually go through it and search for things. You could pipe it into more or something like that, or even redirect it into a file, and then you can search for it and apply grep or something onto it. Well, maybe you noticed before that when I ran grep, I had things that were lit up. So I did ls minus l grep name, and you see that name and name over here were highlighted in red. And the reason for that is that grep is aliased to something else. So alias grep will show me that grep actually runs grep minus minus color auto, which highlights these types of things. Another thing that we like to use is, instead of writing ls minus l all the time, I can do ll. And if I look at the alias of ll, I see that it is alias to ls minus l. And in fact, you see these colors over here. That's because ls itself is actually aliased. So if I do alias ll, I'll see that ls is actually ls minus minus color. So ls, you see that I get all these things lit up. If I want to de-alias things, I can just use a backslash. So if I do backslash ls, you'll see that I get the same thing without the minus minus color option. Or backslash ll will actually have a command not found, because it looks through the path and it doesn't find a program called ll. But when I run ll without the backslash, it looks through the aliases and it sees that it is alias to ls minus l, and so it runs it fine. So aliases are really nice to use. And as I said before, I can look at all the aliases in the machine by writing alias. Sometimes, usually, this will be a very long list. So what I will do is alias and pipe it into less, and then I can use less to look for things, and I can look for something like that on it to search for things, and I can find them. So I can look for LL, and I see that there is alias LL is ls minus l. I can look for all the things that have ls in them that are aliased. I can go to the top, and you see that there are different lines that have that in it. So I can really use less to figure things out over here. You can also create a link, a shortcut to a file or directory for quick access. So that's a very useful thing to do. We call this a soft link, and the command is ln-s. So what that does is we go ln-s and we put a file here. This can be a long directory or something like that. It can be a directory. And then we give a different name, the name of the shortcut we're going to use. And then from this current working directory that we're in, we can keep on just using this short name of whatever the link was, and it can go and look at a file that's somewhere far away or something like that. So we often do this using these links to point at a file instead of using the actual path to the file itself. So I noticed that I have this file under desktop temp that is called really cool file. And if I look at that file, I can do, cat desktop temp really cool file. And wow, it says that this file is really cool, but I don't remember where that is. And I want to have it quickly accessible from over here from my home directory, right? I'm in my home directory and I want to have it quickly accessible. So what I can do is make this soft link, make a shortcut. So I do ln-s and I go again to desktop temp really cool file, and let's call my file cool file. So now if I do ll, right, I'm going to see here that there is this file called cool file, and it's linked to desktop temp really cool file. And if I do something like cat cool file, I'm going to get it's going to go into desktop temp really cool file, and look at it. So it's going to return the same thing as if I did that, right? So that's really a cool thing. If I remove that that soft link, then again, ls-l, I don't have that soft link anymore, but I will see that I still do have desktop temp. I still have that really cool file over there. I can do cat on it as well, desktop temp really cool file. So I didn't remove it just by removing the shortcut to it. So that's a very useful thing, making soft link shortcuts. We're now at the point where we can go and write a very simple executable program. Let's start with a hello world. Okay, so we're going to create a file that prints out hello world. Okay, so we're going to do echo hello world. We used single quotes over here. Single quotes will really print out exactly what's inside here. We want to print echo double quotes hello world into the file hello by redirecting it. So this is going to create this file called hello, which is going to have echo hello world inside of it. Now let's try to execute the file. We do ./hello. We'll try to execute the file, but there is a problem because the file is by default not executable, and therefore we will get an error. So we're going to need to make it executable, and we'll do chmod u plus x hello. It will make it executable, and now we can run ./hello, and it will print out hello world as we expected. But how do we actually tell it to use bash and not something else to run our program? Well, one way is to write source hello. If we run source, and it doesn't need to be executable then, by the way, it will go line by line and take it and put it into the interpreter, which is right now the bash shell. But we can actually explicitly tell it to run bash when we do something like ./hello. And the way to do it is to add what we call a shebang. So we'll first use one of our text editors. I like VI, so we'll do vim hello. When we get into VI, and this is going to confuse you a bit if you don't know VI, but believe me, you'll learn about it at some point. You press I, it turns VI into what we call insert mode, where we can actually go and edit the text. Then we can type something like this, # bang, and that's called a shebang. And then we give the path of the executable of bash, which is the interpreter we want to use. So /bin/bash, and then we write whatever we wanted to write, echo, hello, or whatever else. Okay. Then we do escape. That will exit insert mode, and we do :WQ or :X to save and exit. And now we have our program, which is a bash file. So let's do the example that I showed. So I'm going to do echo, echo hello world, and I'm going to redirect that to my file called hello. And now I'm going to try to execute that. So I'm going to do ./hello, and it says that permission is denied. And the reason that permission is denied is because when I look at that file, I see that I do not have execute permissions to it. So I'm going to do chmod u plus x on hello. And then if I again do ls-l hello, I see that now I have execute permissions on it. And then I can do ./hello. And voila, it echoed hello world to me, which is what I wanted it to do. So that was really cool. Okay. Now I want to actually tell it to use bash. So what I can do is vim hello. And in vim, now what I can do is I can go to insert. I'll add a new line over here, and I'll do a shebang, and then /bin bash, and that will make it executable always using bash. Okay. Really now what I'm going to do is I'm going to write hello and dot slash hello, and that will do it. So another thing is that I could do is I could source the file. Okay, and that means that it'll read line by line and run it. So sourcing hello does the same thing basically as executing it, but always with the shell that I'm using. So it would always be running it with bash. So now I'm going to go over into variables in bash. So a shell, like any other programming language, has variables, and they can be very useful. And we saw that before with the environment variables. For bash, it's really easy. We just write var equals value. So foo equals bar will create a variable called foo that its value is bar. Okay, and this is a local variable. It's only available right now in the terminal that we're using, in the shell that we're using. So now we have this thing with quotations, and you saw that I used it before. Sometimes I use double quotations and sometimes single quotations. When we use double quotations, it will actually dereference whatever variables I have. So if I use echo double quotations $sign foo, it will return bar. But if I use a single quotation, it will not dereference this $sign, so it will actually return $sign foo. So I do echo $foo, and I see that it returns nothing, but then I do foo equals bar, and now if I again do echo $foo, foo returns bar. So that's really cool. But what if I was to do echo double quotes foo? Well, I see it again returns bar, and that's really nice because I can do something like echo foo $foo will return foo bar. Okay, but what happens if I do echo foo $foo, then what it's going to do, it's going to return foo $foo. So it will only dereference the $sign when it's inside double quotes and not inside single quotes. And as I said, variables are local to the shell, and that is for that reason. If I start a program from my shell, it won't know about the variable that I started. Let's say path or home or anything like that will not be known to my shell if it's a local variable. So that's why we have what we call environment variables. And those environment variables are known to any program that I open from within the shell, and then it can access those variables. It can make things very, very good. We can configure things by putting them in environment variables and then opening a program, and the program will be able to access those settings that I set. So how can we see a list of these environment variables? We write env, and env is again going to be a long list, so we can pipe it into more or less or vi or any of these different types of text editors that we have. To define a new environment variable, we don't use the same foo equals bar. We use export. In fact, if we export foo, it will turn foo into an environment variable. But if we directly want to create an environment variable, we use export. So export Charlie equals Brown. Now Charlie will be an environment variable, and we will see it when we print env, or our program that we will start will now be able to access the variable called Charlie. So remember again that I had these special variables that are environment variables, such as echo $path, okay, and or echo $home. These were environment variables. And if I want to see all of the environment variables, what I'll do is I'll write env, and we see that there are a lot of environment variables, and therefore what I will do is I will pipe it into less, and now I can look through the variables, and for instance, I can look for home. Okay, so I see that home appears in many different places over here. There are ways to find the exact home I want, but as you see here, home equals data home Teman AD, and there are a lot of other things that are environment variables over here. What would happen if I wanted to create an environment variable? I would use the export command. So again, I can do something like export Charlie equals Brown, and now let's again do env piped into less. And now let's look for Charlie, and voila, we have Charlie equals Brown as an environment variable, or I can do echo $Charlie, and you see that I get Brown. So that's how I make an environment variable and dereference it. So that now we're ready to actually go and make a whole script. So really, bash can be used to control all kinds of programs and so forth and so on. It gets very useful to make all kinds of batch commands that are run and do all kinds of processes. So therefore, we have ifs and cases and whiles and fors and all kinds of other things, just like other programming languages. We don't usually program deep in dirty things inside Bash. We'll use real programming languages for that, but we'll use it to start up programs and run control flow. So we can also have, with the scripts that we write, we can pass arguments to them. So there are these special things that we pass. $0 is the name of the script. So if my script before was called hello, if I ask for $0, it will return the name of it, which is hello, the name of the file actually. $1 to $9 are the arguments that I can put after the name of the file. $@ is all of the arguments, so it's a list of all of the arguments that I provided. $pound is going to be the number of arguments, and $question mark is the exit status of the previous command. So let's see this very complicated script over here, what it does. So first of all, I use the shebang bin bash, so that means it's going to be a bash script, and it's going to be run with the bash interpreter. The first line is going to have an echo, so it's going to print something on the screen. What is it going to print? It's going to print running program something with something arguments. What is this something? We cite the name of the script. So let's say the script was called hello. So it's going to say running program hello. And let's say that it was hello argument 1, argument 2. So it's going to say it has number of arguments, so 2 arguments. So it was going to say running program hello with 2 arguments. Then the next one is a for. It's actually like a for each. And we provided this $@, which is all the arguments. So it's a list of the arguments. And remember, our arguments were argument 1 and argument 2. So we got a list, argument 1 and argument 2. When we do for file in this list of argument 1, argument 2, do. So the first time, the first iteration, file is going to equal argument 1. So it's going to do a grep. So it's going to look for the string foobar inside argument 1. Okay. And then it's going to do this weird thing over here. Well, this weird thing over here, it says what it is. First of all, if the pattern is not found, grep has exit status 1. So if grep succeeds, then exit status is going to be 0. If grep doesn't succeed, exit status is going to be 1. And as we saw here, there's a special variable called $question mark, which is the exit status. So we know that exit status is going to be 1 if the grep was not found, if we did not find foobar inside the file called argument 1. Okay, then what is it doing? It's redirecting the output to a null register. That just means don't show the output on the screen, don't do anything with it, just throw it away. And to redirect means what do I do with the errors? So if there is an error, then also throw it to this null register. It means don't do anything with it. So it says that over here. Redirect standard output and standard error return null register. It just means don't print anything when you do these greps. Just throw them away, but do keep the exit status of the previous one inside this $question mark. Okay, so now we can use an if. We do if $question mark minus NE0. That means if the exit status was not equal to 0, i.e. it is equal to 1, that means we had an empty grep. Grep did not find any foobar inside the file. Then what are we going to do? We're going to add foobar to the file, and then it's going to echo, write this, append it to the file. When it finishes the iteration, that first of all, the fi finishes the if. When it finishes the iteration, it goes back over here. It'll put argument 2 into file. Again, it will see if foobar is inside the file. If it's not inside the file, it will add it to the file. And then finally, it will finish and exit. So that is a kind of a complex type of a weird script that doesn't do much. But it's just an example of what you should be able to kind of understand and follow now. What if we want to call a script in another language? What if we want to write a Python file, for example? We want to print hello world in Python syntax. Well, then if we do this shebang bin bash, it will try to interpret it with the bash interpreter and it won't understand it. We have to tell it to interpret it with Python. So we do shebang bin Python, and then it will go and it will use Python to interpret it. Make sure that Python is actually installed in bin Python, or maybe you have a different version that is installed somewhere else and you want to put that in your shebang. So now what I'm going to do is I'm going to open up my hello program, and as we saw here, we have this shebang /bin /bash. Okay, but what happens if I replaced my my command to be in a different programming language, let's say like in Python. So here I'll write hello world in Python, and let's see what's going to happen now. So when I now go and I do /hello, it's going to say that there's a syntax error. And the reason there's a syntax error is because it's trying to interpret this as a bash program. If I do source hello, the same thing will happen. Okay, so let's reopen hello and change my shebang. So instead of pointing at bash, it will actually point at Python. Okay, so now I'm going to, I can also look and see that there's a /bin/Python. Okay, I see it's there, or I could have written which Python. Okay, and I see that there is such a program as Python. So now that I changed that to Python again, remember, I changed the shebang, so now it's supposed to run as a Python program and not as a bash program. So now when I do /hello, it is going to actually print hello world as I asked it to. If I source it, it still will not work. Okay. It will again try to run it as bash programs, but it is not a bash program, so that will not work. But when I run it as an executable, it indeed thinks it's a Python program and interprets it as a Python program. So what else do we want to do with our command line? Well, we often want to compress and uncompress files, and the basic thing that is provided with most distros is the zip command. So if we do zip myfile.zip, that's going to be the name of our archive, add these files, myfile.txt to it, it's going to zip myfile.txt and put it in a file called myfile.zip. And of course, we can uncompress it then by going unzip myfile.zip. Now, each of these commands, they have man pages and many options. And actually, the Linux distros will usually have different programs like gzip and gunzip to zip files. But this is the real basic one. Okay. What we do often, and you'll hear this this terminology a lot, is to tar things or provide a tarball. So when we want to transfer a whole bunch of files in a whole directory structure, we usually use a command called tar. And that's a tape archive. We used to archive a whole thing and put it on a tape, and that's where it got its name. So tar with these options, which I guess you just remember by heart, minus czvf, that will create a compressed archive of the whole directory that we tell it to. So the name of the archive, we usually end it by .tar.gz to show it was archived with tar and then zipped, okay? And then we tell it whatever the directory is, and it will take all the directory and recursively go and take all of the things that are under the directory. And when we untar it, and that we do with tar minus xzvf, it will be untarred with the whole structure of the directory. So I can zip a file. So remember, if I had in my directory, I had this files list, which was 1.6 megabytes. I can, by the way, do ls minus lh and then see that it's actually 1.6 megabytes. So what I can do now is I can compress that by writing zip, and let's put it on the desktop, okay, my files.zip, and we're going to add to that files list. Okay, so what it's going to do, it's going to, it says it deflated it by 92%. So let's do ls minus lh on now the desktop, and we see that myfiles.zip is only 127 kilobytes. So that really did a nice compression. Okay, and then I can actually unzip that. So I can, let's cd over to the desktop and unzip my myfiles.zip. And what I see is that now I have files list, which is unzipped, and myfiles.zip, which is not unzipped. The reason I went and changed my directory into desktop, because otherwise it would have unzipped it on my home directory, where I already have this files list file. So I'm going to go back onto my home directory, and now I'm going to show you that I can tarball that whole desktop directory, for example. So tar minus czvf, and then I will call it something like my desktop .tar.gz, and what I'm going to do is I'm going to put desktop inside of that, and there it's going to, you see it told us that it tarred all of these files into there, and what I get is I have this tarball now called mydesktop.tar.gz, and that's its size. I can put that with human readable, and I see that it is 250 kilobytes, even though we saw that there's a 1.6 megabyte file inside of that, as we saw before, but it really made it nice. Okay, now let's go into, let's make a directory called temp. Okay, cd into temp, and then let's untar that tarball that we had. So tar minus xzvf, and I'm going to go and get my desktop tar.gz, and it's going to put it in here. So now what do I have here? I have a directory called desktop, which is what I tarred, and I can look at the directory, right, and see what it has inside. It has, my files and files list and so forth. So that's a really convenient way of tarring things and untarring them. So a bit before we finish, we got to the issue of job control. So sometimes we need to send a software interrupt to our process while it's still running or maybe stuck. So there are three basic software interrupts that we use often. Control-C sends this signal called SIGINT to the process, and usually that kills it. Sometimes it does something else. If we for sure want to kill it, we can do Control backscape. That sends this signal quit to the process, and that really will usually kill it. Finally, we have this Control Z, which pauses a process by sending a sig stop signal to the process. What that does is basically it means that the process stops running and we can continue running whatever we were doing before. So we have a command line and we're doing something, and then we run a process. The process will take over basically our command line, and we won't be able to run more processes. If we do Control Z, it will pause it, we'll get our command line back, and we can continue running things in our process. A common thing to do is to pause a process and then put it in the background by doing BG. Okay, FG will continue the process. Now, the thing is, what if we ran several processes and paused them? So which one do we put in the background and foreground? And we can see by running the command jobs which processes are currently running. So we run jobs, and we'll see all the processes will be in square brackets with a number. And then if we do FG percentage whatever the number was, it will put that process in the foreground, or BG percentage the number, will put it in the background. Now, when a process is running in the background, we can continue using our command line and our other programs while that is still working. And this is often a case where we want things to run in the background to begin with. So by shorthand, we just add an ampersand after it. So for instance, we want to run Firefox. We don't want it to take over our command line, so our command line is unusable. So instead of writing Firefox, then doing Control Z and writing BG, what we'll do is we'll do Firefox ampersand, and automatically it will be run in the background. So that's something that's very common to do. So again, we can move a certain process to the foreground by doing FG and the number of the process, or we can kill it by using kill and the number of the process. And sometimes the killing doesn't work. Often kill -9 is like a forcible kill. So what we can do is we can use a program called xkill, which actually allows us to point at a window, and the desktop manager will often be able to kill the process. Be really careful when you use these things. So now let's go over to see how job control works. So if I was to do something like, a find command on the root, what I'm going to get is a long list of stuff that's going to take a long time to read. So I can press Control C, and as you see, it canceled it and killed it. Let's do that again, okay? And I can press Control and backslash and kill it as well. So those are two ways to kill it. But let's say I didn't want to kill it, I wanted it to continue running. So I could do find and find again, and then if I do Control Z, then it just paused it. And then I write jobs, and you see that I have a task number 1 is stopped, and that's task that's called find, and I can return it to running by doing FG %1. I could just do FG as well. It would understand it's %1, and it continues running it. So these are kind of the things that I can do with this software interrupt type of a thing. Right now, when I look at jobs, I don't have any jobs left because I killed that job. Okay, that is kind of the things that you can do. Another thing that's worth checking out with the foreground and background jobs is I can start things running in the background. So let's say I have this program called Events, which is a PDF viewer, And as you see, now I have my PDF viewer open and I can play with it and do all kinds of things with it. But this is dead. I can't do anything really. Let's say I want to do ls minus l. Doesn't work. My screen over here is basically dead. So what I can do is I can kill this, right? I can stop it and then I go back over here and then it had in the buffer ls minus l and ran it. But I want to have them both running at the same time. So one way to do it is to run again events, okay? And then go back over here and do Control Z. It will stop that, so it's now paused. And look, I can go over to events, but now I can't press on anything. It's kind of dead. The process is paused right now. So what I can do is I can again do FG. It will return it to the foreground, and now I have that in the foreground. Okay, but I don't want it in the foreground, so again I paused it. I can have it in the background. So again, if I have the jobs over here, so I can do BG number 1. And now events is running in the background and I can do different things with it. Okay, so I can play around with it again. So I did that. I can also, again, I can kill it, right? So kill, usually -9 is a really hard kill. Okay, and I do number 1. And let's see, did it kill it? It did kill it. I have something else open over here, but yes. So I was able to kill events, but the way that I can really run it automatically running in the background is to run it with this and sign. So events and now I have my events over here running, but I can still use my prompt over here. So ls minus l is still going to work. So that's often what we do is we run things in the background like that. And you see that events is running in the background. And now it's number 2. And again, what I can do is now I can kill it. Again, kill number 2. And let's see, okay, I don't have events running over here. No more jobs running. So that's running things in the background and killing them. We can also use the PS command to see all the processes that are running. PS will show the list of all running processes in the current terminal, but if we use PS minus U username, it'll show all the processes that our user is running on this server. Okay, PS minus A will show all the running processes, and there are going to be a lot of them. For a graphical representation of these different processes running, we can use the top command, which we can see over here, a screenshot of that, or the htop command, which we can see is a bit more pretty, but this is kind of the classic one. And if we look at the top command, it provides all the processes that are running on the server and all kinds of data about how much CPU usage there is and how much memory there is and so forth. And you can do all kinds of things in it, like sort all the jobs according to one of the columns. For example, the memory column. You want to see who's hogging all the memory on the machine and why your machine isn't working. So you hit Shift M and it will put the process that's hogging everything at the top, and you can see who the user is and call them up and tell them, either tell them or the system administrator to kill their process. Another thing is you can just kill a process of yours that's become a runaway by pressing K and then entering the PID over here, the process ID, and it will be able to kill the process. So another option for, process control and so forth is the top command. And the top command gives me this type of a view of all the processes that are running and so forth. And what I can do, for example, is I can hit U and it'll say which user, and I only want to show, say, the processes for my user. So I write Teman AD, and you see now it only shows me the processes that I'm running and their process IDs and so forth. And I can do something like Shift M, which will sort it according to how much memory they're using. I can also do Shift right arrow or left arrow. It will change the column which is used for sorting. There are all kinds of different options over there. And I press Q to release that. There is a more kind of colorful and nice looking version which is called htop. So I can use that as well. And Q will also go out of that. So before we finish, I'm going to show some more cool commands. So let's start with the sort command. So if I take some sort of a file that has names or something in it and I do sort names, it's going to sort it, or sort -R will sort it according to reverse alphabetical order. Okay. One thing that often happens is that I have duplicates inside a file. So I can use unique, like to uniquify the file, and then any two lines that are exactly equivalent will be unified, and the second line will be deleted. But that doesn't really help because the lines may be scattered throughout the file. So often I will sort them, take the output and pipe it into the unique command. Another thing I can do is count the number of words in a file, actually the number of lines, the number of words, and the number of characters, and that's the WC, or word count command does that. So if I do WC on names.txt, it will tell me how many lines there are in the file. So what I can do actually is to sort the file, then uniqueify it to get rid of duplicates, and then count count the words, and that will show me how many names there are inside the file. So these are kind of cool things that I can do. There's a lot more you can do in Unix. So a final few things I want to show. So let's go back to my home directory. So I'm going to go cd tilde is going to go back to my home directory. And remember that we had a file over here that was called names, and that I prepared a few names. So if I look at that file, I have all these names, Joe Blow and John Smith and Charlie Brown and so forth inside this file. So what I can do now is I can do a sort command on names, and you'll see that now it put it in sorted order. So it starts with C, D, J, etc. I also have some names that repeat themselves, like John and John Smith. By the way, I can also do sort -R on names, and it will do it in reverse order. So what I can also do is I can run a unique on names, and I see that it didn't do much. I still have John Smith over here and John Smith over here. So what is commonly done, I will do sort names. Okay, that puts John Smith next to John Smith over here. And after I do sort names, I will pipe it into unique. And then I only have one John Smith in the file. So that's something that I often do to remove duplicates. Now, another thing I can do is I can count the number of lines I have over here. So word count on names says that there are 12 names over here, 22 words and 132 characters. But what I'd often want to do is I want to first unique things. So I'm going to, again, sort names, pipe it into unique to get rid of the duplicates, and then count the number of words. And I see I'm only left with 11 names over here, 20 words altogether, and 121 characters after I got rid of the extra John Smith. This is the end of this introduction, and it's been a long but short introduction to Unix. There's a lot more you can do with Unix, Linux, and so forth and so on. So this is really just the beginning. And if we go to, if you start to use Linux already, you better get familiar with XKCD, which is where all the geek comics are. And you can see this true story about Linux, where week one, you call up your cousin, ask him to help you install Linux on your computer. Week two, Xorg is broken. What's an Xorg? Where can I look that up? Oh, well, let me show you some man pages. By week 6, due to autoconfig issues, I'm leaving Ubuntu for Debian. Those are two different distros, just for you newbies. Gentoo. By week 12, you haven't answered your phone in days. Can't sleep. I must compile the Linux kernel. I'm too late. Parents, talk to your kids about Linux before somebody else does. So that was all, and I hope you enjoyed.